Hi guys, and welcome back to Elevate Chem. It's Jesse here with another concept video. This is our second video in our 5-part series which will be covering redox. Now, as always, we're going to be looking at a question because ultimately the best way to learn a concept is by learning how it's applied in an actual exam. And as always, the first thing I want you to do is have a crack at this question. It's the VCE 2011 Chemistry Exam number 1, and it's question 5. And I actually just want you to stop at the end of A. So just AI and AII. So pause the video, have a crack, and I'll see you on the other side. Fantastic. So I'm going to get started on it myself. And the first thing that I always do is actually ignore all the text right at the top because I don't know what I'm going to need right yet. So I'm actually going to jump into the question where it says, write a balanced half equation for the oxidation of TeO2. And in the question it actually tells me that this is called tellurite, but I'm just going to call it TeO2 for now. So it says write a balanced half equation for the oxidation of TeO2. That means, of course, on the left-hand side, TeO2 must be oxidized. So I'm going to add that in. Now it's a mineral, so I'm going to assume it's a solid. But if I wanted to check, and in fact what I'm actually going to use for a lot of my information here, is by actually referring to some information they give me after the question. Always be out on the lookout for this, guys. They might be a little bit sneaky and give you some additional information you need after the question that's actually given. And it might not always be needed, but it certainly is helpful. So we can see here that indeed TeO2 is a solid. Now, TeO2 is being oxidized. Well, what is it being oxidized into? It says up here in this reaction, TeO2 is converted into H2TeO4. So I'm going to write that in right now, that it's converted into H2TeO4. And what state does it have? Once again, I'm going to refer to this balanced chemical equation, and it says it's aqueous down here. So I'm going to add in my states. Make sure you always add in your states. Now, what else is going to be produced? Well, it's oxidation, so I know that some electrons must be released. I don't know how many yet, but I know some must be released. Now, in terms of what's actually causing the oxidation of the TeO2 within this chemical equation here, well, let's look at this balanced equation. I've got TeO2, I've got my dichromate ion, and I've also got my hydrogen ions. None of these things, amusingly enough, are actually going to be able to help oxidize TeO2. And instead, we're actually going to have to look to the right-hand side of our equation, and we see that we've got water kicking about. Now, hopefully you know that water is certainly something which could fill in this role. But why isn't it featured on the left? Well, that means it's going to actually be cancelled out by some of the water that's produced by this reduction equation up here. So I'm going to add in water, and of course, that's a liquid. And again, I'm going to leave it out the front in terms of what the coefficient is because I'm not sure yet. Fantastic. Now let's start balancing this equation because I should have most of the elements that I need. Now, my Te and my Tes are both balanced, which is excellent. My oxygen and my oxygen, they're not balanced. I've got 3 oxygens on the left and 4 on the right. So I'm going to make that a 2 coefficient of my water. And now I have 2 plus 2. I have 4 atoms of oxygen and 4 on the right. Fantastic. On the left-hand side of the reaction, I have 4 hydrogen atoms, and on the right, I currently only have 2. So I'm actually going to add in 2 H plus ions right there. Awesome. I've now balanced all my elements. Time to balance the charges. On the left-hand side, I've got a neutral charge, which means on the right-hand side, I also must have a neutral charge. And that means all I have to do is add that there's 2 electrons rather than just 1 to make sure that these 2 charges cancel each other out. Awesome. Now we're going to use this information and also the half equation for the reduction to finally balance and work out the coefficients for this full balanced chemical equation. Now the first thing that I need to do, and hopefully you guys will cotton on to this, is that if you notice there's no electrons within my balanced equation, and that should always be the case. If there's one sort of standard rule for these things, is electrons should never be present in your final equation. Well, how am I going to get rid of them? I'm going to cancel them out. And I have 6 electrons on the left-hand side for my reduction. I only have 2 on the right-hand side for my oxidation, so that means I need to multiply this equation by 3. That's going to give me 6 electrons, and they're going to cancel out with those 6 electrons. Now all I need to do is fill in the relevant coefficients. So my TeO2, there's going to be 3 lots of it because I multiplied it by 3. For my dichromate, there's only 1, and I didn't need to multiply the reduction reaction by anything, so I'll put in a 1. For my H+, it's a little bit more complicated. On the left of my reduction, I have 14, and on the right of my oxidation, I've got 2, but remember, I'm multiplying by 3, so that means I actually have 6H+ on the right-hand side. They're going to cancel out with some of these and leave me with 8H+, so I'll put 8 just in there. Now I'm looking at the right-hand side of my equation. This compound here, H2TeO4, again, I only have 1 within the equation, but I'm multiplying it by 3, so I'll stick a 3 in front of there. My Cr3+, I only have 2, no need for any sort of multiplication. And for my water, well, for my oxidation, I have overall 6 on the left-hand side, again, 2 times 3. But I'm going to have 7 on the right-hand side. Subtracting the 6, that leaves me with 1 molecule of water left over. Fantastic. So hopefully you got most of that stuff, guys. Now the things that I think were important to actually really focus on in this question is using materials from other parts of the exam to assist in answering your questions. And the other thing is potentially this common misconception that you need to make sure that you multiply these electrons by 3 to make sure they cancel out. I see a lot of students just leaving electrons in the final answer, and in this one, thankfully, there wasn't really an option for doing that, so it's giving you a bit of a hint, but make sure you cancel out those electrons, and most importantly of all, make sure you look around to see if there's any extra content within or around the question that you could use. Great, guys. I look forward to seeing you next episode.